was on the World Cup lesson.
Oh, yeah?
Or the World Cup example where we're supposed to illustrate a graph. Like I got the mean and the standard deviation and the sample size for all that, but I was trying to figure out how to take that information and, get the independent sample test. Because it talked about having to go in and renaming a group or something.
Mm-hmm. All right, let me see.
Anyway, so do you know how to do that?
So in the World Cup one?
Yeah.
Okay, so, but you already got the like summary statistics?
Well, yeah, I just copied and pasted all the numbers for the control and got the
All right, I'm opening up the thing right now. So, the main question is like you want to find out how to
in the reading. It says give the relevant summary statistics for the World Cup thing, and I figured out how to get the mean and the standard deviation and the sample size for each of them. I just copied and pasted the numbers into a new cell, a new column, and figured out, made it did an explore thing on them, and got that. But now I need to get to the point where I can make the 2 histograms.
Oh, okay.
Because they had with the reading deal with the other group with the other data for the reading groups, they had you somehow separate them into 2 groups.
Yeah.
So I don't know how to do that for this World Cup one.
Yeah. Okay. So, do you have like that data thing open? All the numbers?
Yeah.
All right. So you see in the like time period column?
Time period? Yeah.
You see how it says control, and then it says World Cup?
Uh-huh.
So those are the 2 groups. So then, if I remember correctly, go to transform.
And then do you do automatic recode?
Yeah. So then the variable, which is going to be the new name, you want the time period because that's where it has the 2 groups.
Okay.
So then you click on time period, you move it in there, and then you click down where it says new name.
Okay.
And you can type in time period code. And then hit add new name.
And then okay.
Then just hit okay. So then you should get the control group as code 1 and the World Cup as code 2.
Okay.
So then from there to get the histogram.
Let's take it.
Okay, just let me know when you have it.
Okay. Xing out a bunch of my windows. It's gonna get bogged down.
Yeah.
Okay. Okay. So I've got that. I've got the group 1 and 2, or I've got the groups. And now, what do we have to do?
Now to get the, if you want to find the, or get the graph, the histograms. So then normal, go to analyze, graphs, legacy dialogues, and open up histogram.
Okay, but if we do the analyze one with the compare means and the one sample t-test, will that give you the histogram too?
The independent sample t-test?
Yeah.
Let me check, or maybe it's theirs, because, let me see, analyze, compare means. Let me see, I think this gives you the, doesn't this give you,
To find,
yeah, I think this gives you the, let me see, yeah, this gives you the, see, if you want to go into it, just go into analyze, just compare means, independent sample t-test. So then in the test variable, what you're measuring is like the heart attacks. So you'll move that into there. And then down below it says group being variable, and that's where you'll put in the groups. And so you'll move the time period code in there.
Okay. And then define groups, and you just do 1 and 2?
Yeah. And then hit OK. And that will give you like the mean, standard deviation for both the control group and the World Cup group.
Okay. Now, then my thing was trying to figure out
the graphs.
Okay, so I know how to do the graphs.
You know how to?
The histogram?
Yeah.
Yeah, I'll go back and make sure. Because you just go to graphs. Hang on, let me ask you this question. For like the test statistic and the degrees of freedom, how do we know which one is which?
What do you mean?
On the independent sample test chart?
What I was reading is that you always use the equal variance is not assumed. So that's always going to be the T, like the T, the difference, the freedom, and like the P value. It's always going to be that row and not the top one.
So we get it, that's for both of them. We don't have to find it individual, like this is group 1's T statistic and this is group 1's degrees of freedom. That's a combined.
Yeah, I think so, because that's what I was reading, at least towards the end of it, where it says that you always use the not assumed one.
Okay, that's what it says. All right. Okay, that's all right. I was hung up right there. Yeah. After I got off on Tuesday, I got really sick. And so I've just got a lingering headache, and so I'm not all there yet. Okay. Yeah. So now the histogram you go to histogram, and then what do you put in the variable box? Heart attacks?
Yeah, because that's what you're measuring.
And then you got to do you got to put something in the rows.
Yeah, so you would put the time period code.
Time period code. Okay. Okay. So basically that's what we did this, because I didn't get through all the way the reading, but that's basically what we've done the whole time.
Mm-hmm.
And this is just doing those over and over and over.
Yeah, there's like 3 examples.
Okay, so I didn't get to do the one past the World Cup because I couldn't. Okay.
And then towards the end, it just tells you how to find the like confidence intervals.
Okay. So. Okay.
Right.
So to do the confidence intervals.
Because it's automatically the 95%, but I think to change it, you go into, let me see if I remember. Okay, yeah. So you would go.
So you get the confidence interval from your independent sample test.
Yeah. So if you wanted to change it, you would go into analyze, independent, analyze, compare means, independent samples, t-tests, and then you would put everything in like we did, and then you would hit options, and there you could change the confidence interval percentage.
Okay.
Yeah. And then again, if you would put 90 or whatever, you would use the equal variance is not assumed row. So it would be that one.
Okay. A matter of graphs, right? Putting information in.
Mm-hmm.
Right. Okay.
Yeah. So I hope that helped out a bit.
I'm getting out my preparation assignment here.
Okay.
And David said he wasn't coming on.
No, okay.
Something about his internet switched.
That's fine.
So what is the difference between matched pair and independent sample? You're just comparing different things.
So, oh, okay.
Let's see.
Match paired data. The match paired, I still really don't. I kind of get it, but just like the matched pairs where the
Well,
groups depend on one another.
Yeah, and like you could have the same person. It's like you're comparing the same person with a later. You're
Yeah,
testing
like
them later, so you compare the same thing with
more than once.
Like with the weight loss deal, you've got one person, and then you're observing them later. It's still the same person.
Oh, okay. And the independent is just.
Yeah, like if you take a man's salary and a woman's salary and compare them, they're two different people.
Okay.
They might have the same job in common, but they're two different people.
Okay. All right. So just says complete the chart below. In the left-hand column, fill in the name for the four quantitative hypothesis tests we have completed thus far in Unit 2. So the first one is just a hypothesis test for one mean sigma known. The requirements are it has to be from simple random sample, population, the distribution, sample means is normal, and sigma is known. Name of distribution from which the test statistic is computed, normal distribution, and then the null hypothesis and possible alternative hypotheses. So the null is sample mean equals what is it, the sample?
That's the null hypothesis is equal to what is that?
Yeah.
The null.
Do you want to go over all those?
Well, I think the next one is when sigma is not known.
Mm-hmm.
Deviation is not known. And then the other one was
The paired
data, and the other one was the independent sample. So basically, the requirements are all the same.
Yeah.
And the name of distribution is all the same. They have to all be normally distributed.
Mm-hmm.
And then the only one that starts to get different is an independent sample where you have like X1, S1 and N1.
Yeah, and then X2. Yeah.
Oh, I didn't do that, but I'll go back and fill it out. Okay. So let's try to do this part 2. Okay, so we need to get the class survey data.
Class survey. So mine is still pulling up. It just
Oh, yeah.
says one of the professors in the BYU Idaho Math Department collected data from BYU Idaho students to compare the mean wages of BYU Idaho male students to BYU Idaho female students. The students from his classes completed a survey which he then used to analyze if there is difference in these wages. Use the class survey data to complete this problem. So 1A, what is the research question? Just if wages are different.
So is there a difference in the wages?
Yeah, between genders.
Okay, so the null hypothesis, I gotta figure out how to write this again.
Oh, no. Don't know.
So it's going to be like U1 is equal to U2.
Yeah.
And the alternate is U1 is not equal to U2. Or well, wait a minute. Well, yeah, because it's just asking if there's a difference.
Yeah.
So, whoa, there's a lot of information on here.
So,
The wages.
is there? I haven't seen it. Whoa. What is that?
Yeah, I'm wondering how do you separate the gender? That's what I was wondering when I was doing the other deal, but luckily, it had all for the World Cup, it had the control all together, so I just copied and pasted it all.
Yeah, let's see. Huh. So what we want to measure is the wage, right?
Yeah, can it recode the gender into groups
Oh, wait.
or something so they're categorized?
Let's see. So yeah, because I just did the what is it? The automatic recode, and so then I put, because the groups are the genders, so I just put gender in the variable, and then I put gender code, and then I just put OK. And so automatically it looks like the males are group 2 and the females are group 1.
Okay, I did for it to. Okay, so now that you have that information, how do you find the mean?
You go to
Analyze, compare mean,
yeah.
and the independent sample t-test.
Yep.
So you're going to highlight weight
Yeah.
and the grouping variable. You're going to do gender code, right?
Yeah.
Define groups 1 and 2. How do you know if you have the right group, like 1 and 2?
Oh, that's what I was thinking as well yesterday, and right now that I plugged it in. But I think it automatically, I don't know, I think it just kind of like does it, kind of like the automatic recoding. Because
Okay. Well,
I just put like for group 1, I put like 1, group 2, I put 2. Because I don't know.
So it should match up. The group 1 is females, group 2 is males.
Yeah.
Okay.
Yeah. And I did.
Okay.
Yeah.
Okay, so with those statistics, we have the sample size for female is 91. So you would go like what? X1. No, okay, so X1 would be the mean. So X1 equals 9.7592. Do we round that?
Yeah, I would round it to the 3 decimals like we always do.
So 9.7. You gotta get your 10. They just told me. Oh yeah. But it's not. Okay. So what is it asking? The degrees of freedom? Can you put on me? Mommy, can you?
Alright.
I think I did it wrong.
Wrong?
Mommy. Yeah, because I don't have them in 2 groups.
Oh, okay.
So I'm wondering what I did wrong.
Did you put?
Oh, I didn't do independent. I did 1 sample.
Oh, okay.
Just a second. What do you want, William? What do you want? I'll change your shirt. It's dirty. What? Don't you put the city in the test variable?
Or let me see. Yeah. The city and the variable new name. Because the city, they're the groups. So that's what you want to separate.
Okay, so I've done that. But now I'm trying to do the independent sample
Oh, okay.
And
So then independent. So then yeah, you would put the test variable is the dentist bill because that's what's being measured.
Okay.
And then the grouping variable, remember it's the groups. So
Okay.
it's the city. Yeah.
Okay. Don't change your shirt. You've got cookies all over it. Okay, I've got it now. So the degrees of freedom It's 37.996.
Yeah.
37.9. What's the sample standard deviation for Rexburg? T- 206.637.
Mm-hmm.
What is the test statistic?
-0.434.
-0.4. What is the p-value? Oops. 0.666.
We would divide that, right? Because of it's one-tailed.
Yeah, I didn't look at the.
Because at the number
Yeah,
6.
greater.
Yeah.
Okay. So 3.333.
Mm-hmm.
What is the correct? Okay, what was our? Is it 0.05 or
0.10? Yeah.
So we failed to reject the null.
Yeah.
Suppose your alternative hypothesis is they are not equal to each other. What is the correct decision based on the evidence? It's still the same.
Yeah, because it depends on the
P-value.
Yeah. So just
Wait
filter reject.
No. We just have to, that's a tricky one because you have to remember that the p-value is going to be bigger now.
Oh yeah, because it would be 0.666, right?
Mm-hmm. But it'd still be bigger, so
Yeah.
you'd still fail to reject it.
Okay, that's true.
Use the data file, freshman dinner. Okay.
Freshman. Mm-hmm.
Okay, so I've got that file up. Let me see what it's asking.
Okay, I'm just waiting.
I'll just read. It says the data represents the number of times freshman students from Utah and Colorado cook their own dinner in a month. You suspect that freshmen from Utah cook dinner for themselves a different number of times than freshmen from Colorado. The null hypothesis is that they are equal to each other. Use the significance level of significance as 0.005. So It's just saying that, so it's asking for the alternative hypothesis. It's not
Yeah.
saying that you expect that Utah kids will cook them
More
more
or
or less different. So it'd be just the not equal to.
Mhm. Okay.
Okay, so I gotta go back to our thing and figure out our data.
Okay.
So transform, automatic recode, and are recoding the states. So when you do the independent sample t-test, the variable is the freshman, right?
Mm-hmm.
And the group is the state code.
Yeah.
Okay. Okay, I've got my information up. Let's see what that question was. It says, what is the test statistic? So I have a negative 0.845.
Yeah, that's right.
Okay.
So next one is asking what is a p-value, and I got 0.410.
Okay. What decision do you make? Okay, so it is larger than the level of significance.
So we failed to reject the null hypothesis.
Okay. Now use information and data just above the question 12 to construct a 95 confidence interval. Use information just above 12. Oh. Okay. So, do you have your confidence interval?
Yeah. So for the lower limit, I got negative 5.137. And for the upper limit, I got 2.204.
Okay. Now, I'm just wondering if they're throwing you off with this information. Now use the information and data just above 12 to construct a 95. Yeah, we're right.
Yeah.
Just wondering if they're giving us extra information. Okay, so I gotta type these in. The lower was 2.
No, the lower was negative 5.137.
Okay, and the lower or the upper limits, 2.204.
Yeah.
Oh, we're done? Yay.
Yeah. Yeah.
Okay. So,
All right. Well, I'm going to go over them real quick.
Yeah.
Okay, so 3 is A and B, 4 is T-score, 5 is knowing which subjects are in group 1 tells you nothing about which subjects will be in group 2. 6 is 37.996. 7 is 206.637. 8 is negative 0.434. 9 is 0.333. 10 is fail to reject the null. 11 is fail to reject the null. 12 is U1 is not equal to U2. 13 is negative 0.845. 14 is 0.410. 15 is fail to reject the null. 16 is negative 5.137. And 17 is 2.204. Alrighty. Did you get them all, Sadie?
uh-huh. I got a big smile on my face because we got it right. Yay!
Yay, good job.
Cool.
That was good.
Yeah, the only thing I was wondering is if we would get the confidence intervals wrong.
Yeah. Yeah,
Cool.
it's making a lot more sense now, so. Yeah. All right.
Cool. So when is our next test? Do we still have 2 more weeks?
Yeah.
2 more weeks for another test.
Yeah, so it's a couple more chapters.
Okay. Sounds good.
All right.
Well, it's Thursday. Have a good weekend.
Yeah, you too. Hope you feel better.
Yeah, I think I'll be talking my game next Tuesday.
All right, sounds good.
Okay,
All right,
see ya.
bye. Yep, bye.